Hello again everybody in my physics class. Just keeping a promise that I made to you earlier. I'm going to be working through question 3 on page 3 of the workbook. And this is looking at the homework. That to me looks like an NCEA level 2, NCEA 2 sort of merit question, possibly even at the bottom end of excellence. So I thought I'd work through it with you. Here it is. It's in 4 parts, A, B, C, D, and I've got part A started. The velocity is equal to the frequency times the wavelength. That's where I'm going to start. Rearrange things. The wavelength will be equal to the velocity divided by the frequency. Put the numbers in. Velocity of the speed of sound in air is 339, and the frequency they give us, which doesn't change, is 1350. That's a little bit over a quarter. That's 0.251 meters, I think it is roughly. However, I'm not too worried about that last little bit there. 2 significant figures is enough here. Moving on to the next one. This one here is an interesting one. Sound does not speed up or slow down when it is in one medium. So therefore, because it's in air and is going at a constant speed, we can use year 10 speed, distance, time stuff. However, we don't want to know the velocity, we want to know the time. So what I'm going to do here, it may seem a bit odd, but I'm going to show you a bit of algebra here. I'm going to write it out again. I'm going to divide both sides by v. That's kind of useful, even though it looks a bit odd. I'm then going to multiply both sides by t. The cool thing about that is the v's cancel and the t's cancel there, and we're left with t is equal to d over v. I'll just cancel those again so you can see the link. The cancellation will disappear shortly. Now we can put our numbers in. The distance is 1400 meters. The speed of sound is 339, and that's a little bit over 4 point something seconds, and that's good to know. I believe that's the answer in the back of the book too. Now, this last one here. Would you expect the speed of sound in water to be greater than or less than the speed of sound in air? Explain. I said, like the book, that it would be greater, but I used a different reason from them. Both are right. The reason I gave is the molecules of water are closer together, so therefore they don't have to move so far to bump into each other, and the wave of sound can move along a lot faster. The answer in the back of the book says that the wavelength in water is 1.1 meters, and we work out the wavelength in air as 0.25 meters. Now, if I use a space here, speed is equal to f lambda. The frequency is constant, so the speed is proportional to the wavelength, which means if the wavelength goes up, the speed goes up. And that's what they've said. The wavelength goes up from 1/4 meter in air to 1.1 meters in water, so therefore the speed of sound is greater. Okay, moving along here. Speed of sound in water. Use our old formula here, v equals f lambda. Put the numbers in. The frequency is 350 and the wavelength is 1.1, and we get the speed of sound as 1485, and that's a blue screen because it's a nice place to finish. And I think that's even what they said 1490 in the book. Anyway, I hope that's useful to you, and I'll post this as soon as I get it all processed. Cheers, guys.